Thanks a lot for this introduction. Here in Switzerland, I would say Grüezi miteinander, Servus in Austria. I'm speaking to you from Empa in Switzerland. You see it here very small on this picture. Traveling to Vienna, it's a little bit more than 500 kilometers by airplane. I would have caused 126 kilograms of CO2 equivalents if I would have taken the airplane from Altenrhein, a small airport that is close here to my hometown of St. Gallen. Instead of taking the airplane, I could have taken the train with the Austrian Bahn. It would be about 67 kilograms of CO2 equivalents to travel from St. Gallen to Vienna and back in the order of 530 kilometers. Or third option to travel would be take my car. It's about 630 kilometers. If I'm traveling alone in the car, I would cause more than 400 kilograms of CO2 equivalents. Now I have chosen my computer to make my presentation. And the question then is, what is the CO2 equivalence that I'm causing by presenting here from St. Gallen to you in Vienna, my talk? And with that, we are somewhere in the topic of my talk. What is the sustainable use of ICT? Is it what I'm doing at the moment, presenting from far away to you? Let's come back on this at the end of my presentation. I try in coming 15, 20 minutes to touch four blocks. What means sustainable as a first question? As a second question, how can I measure this sustainability? And then looking on the impacts of ICT and on issues like the proportion. So how relevant is this? And what are substitution effects? What else is happening if I have these impacts of ICT? Sustainability. The classical definition is from 1987 from the Brundtland report that says sustainable development is a development that is able to meet the needs of us from our present generation without hindering future generations to meet their respective needs. Or if we want to write this in a shorter term, we can say we haven't inherited the earth from our parents, but it's rather something that we borrowed from our children. And this view towards future generation makes the environmental perspective within the whole sustainability discussion so important. So the strong requests about resource conservation and environmental protection comes mainly from this view towards future generations. Now, how can I measure this sustainability? The environmental sustainability I can very well measure with the life cycle assessment method. LCA, life cycle assessment, that's a comprehensive approach that is quantifying the ecological and the human health impacts that a product or a service causes along the complete life cycle. Human health is taken into account as you and me, we are part of the environment. So anything that causes negative impacts on the environment usually causes also negative impacts for human health. LCA is based on scientific methods. Usually we model steady state, global environmental and human health impacts. And in that sense, LCA can then help decision makers to understand let's say the dimension that the environmental impacts of a product have and can be taken into account as one part of a decision-making process. The start is a life cycle model of the system we want to look, like the model that you see here on the left side on this slide, starting from the material extraction, going over the production, transport, utilization to the disposal or recycling of a material. And what we do in LCA is, in a first step, we simply try to collect for all these steps, all the input and outputs of these steps. So means all the resources, materials, energy that goes in the different steps, and the emissions, the products, the wastes that are produced in these different steps. And I can sum these up, and then I have a total resource consumption and emission production that my system is causing. And in a second step, we then assess these resource consumptions, these emissions that are occurring according to their environmental relevance in what we call the impact assessment. And the higher a bar, the higher the impacts on the environment that are caused. What you see here is the example of different shopping bags. Here, the first one, that's a plastic bag. The last one, that's a cotton bag, showing you that from an environmental perspective, a plastic bag has a much lower environmental impact than a cotton bag. But that's not the issue here of my talk. I'd like to talk about the impacts of ICT. If we look on ICT, the technical developments over the past years, they have been very fast. Some years ago, we had a huge desktop computer with a cathode ray tube monitor, so huge devices on our desks. And nowadays, we have tablets, we have smartphones, which are much smaller and even more performance than these old desktop computers. But are we maintaining the gains that this reduction in the material and in the energy consumption of these devices brought with it, also from a societal perspective? We were looking really in details on the entire life cycle of such devices. So really looking on the production, looking on the use phase with the electricity that these devices are consuming, not only in the active phase, but also in a standby. And some old devices, even when they were off, they were consuming some energy. And in the end, the dismantling, the disposal, the recycling of the materials. And the question there is, what is now an adequate, a fair way of expressing the impacts that these different devices have? And I show you the example comparing a desktop computer, a modern one with a flat screen, with a laptop, and with a tablet. So, I mean, in a first step, I can simply say, okay, I look on a per hour impact that these devices have. And then we see, what you see here is the global warming potential, so the carbon footprint in a way. And with recipe, that's one of the methods that we have in LCA that allows us to make a kind of an overall environmental impact assessment. So taking into account all the different environmental issues. And you see the result is quite similar. The desktop computer has a much higher impact, about 5 to 10 times higher impact than a tablet per hour of use of these devices, taking into account the different lifetimes of the devices. Now, if you look at home, probably this picture here shows quite well how ICT at home developed. 10, 15 years ago, there was just one family computer and everybody had to use this single computer. And nowadays we have in each room of your children, you have a laptop, you have a tablet, you probably have smartphones, at least as many as you are members in the family. So we have much more devices at home, and that means that we are using them also in a different way. And so looking on the impacts per hour of use is probably not the adequate way to do it. Rather, we should look on the daily impacts of the use of this mix of devices that we have. And if I take such a pattern here, then in the end, what I see is that, yeah, okay, I have a lot of smaller devices, but I use them much more. So in the end, this is somehow compensating the more material intensity that I had in the past in less devices. But still, this is not the complete picture, because this is only showing what you have at home. But in order that I can do my presentation now towards you, we need a whole infrastructure between here, St. Gallen, and Vienna, the internet, with the access points, with the switches, the routers, the optical cable, and so on. And on the other hand side, the millions of servers that are stocking the information when you are exchanging documents, and so on and so on. And so if we take this into account as well, here the impacts of a download of a certain amount of data, we see that, oops, the orange part, that's the internet. The impacts from the internet are probably even more relevant than the impact of our devices that we are using. And again, on a time scale, the download speed over the past 20 years was increasing, which means that nowadays we are much more longer connected with the internet than we have been connected in the past. And so if I sum up such a scenario, then we see that obviously the internet impacts are the main impacts. And overall, we see that there is a clear increase of the daily environmental impacts due to the use of the different ICT devices that we have in a family nowadays. Now we have seen the impacts just of ICT, but we have to put this into context. I mean, you are getting up in the morning, you have breakfast, sometimes you're reading newspaper then on paper, some are reading the newspaper on a tablet or on a smartphone. You go for work, you're sitting in front of your screen during the work. In the evening, you sit in front of the television or you're reading. So there are a lot of elements during the day where we are in contact with ICT. And if we look on, I have numbers for Switzerland. I mean, the Swiss citizen, they are not yet in a 2000 watt society or a 1 ton CO2 society. So in this green bar, we are somewhere like a lot of the people clearly beyond these numbers. And if we then look where this is coming from, I mean, the ICT use is part of the household electricity. So that's for the global warming potential in Switzerland, a rather low part. So this is this small orange bar here. For the cumulative energy demand, so the gray energy there, the electricity is more visible. And if I then look on an overall environmental impact assessment, again, it's a rather small part due to the, let's say, rather green electricity mix here in Switzerland, with a lot of hydropower and nuclear power. If I compare this with other sectors, here a different presentation for the consumption production in Switzerland, we see education and communication, the impacts per Swiss and per year here shown. Most of it taking part abroad means most of it taking part when these devices are produced that we use for communication. And what we see here very well is we have 3 other areas that are clearly higher concerning their environmental impacts. One is the whole issue of housing, the energy consumption mainly there for heating our houses, the whole issue of nutrition, so the whole food production, and the mobility sector, so driving around, flying around, taking the train. These are the 3 areas that show clearly the highest environmental impact. So communication, ICT, we can say is rather sustainable because we are rather low in the environmental impacts there. Now, there is a last element to have a look. That's why we are using our ICT devices. We don't do something else. So there is a kind of substitution, I think very well shown in this photo here. You can read the newspaper traditionally on paper, or you can read the same information on a tablet. let me make a first example here. ICT replacing paper. If we look on how a supermarket can make its advertisement, he can make it with television spots, environmental impacts of a television spot. Here again, the global warming, the grey energy, so the cumulative energy demand, and with the Swiss eco points, a third method that allows me an overall environmental impact assessment. You see here the impacts from television spot. The supermarkets nowadays, they have a website. I can go with different means on such a website, and depending if I'm using a desktop or a mobile phone, obviously the impacts for the access, for the internet access are the same. That's the orange part, but the impacts from the device are very different, because a smartphone, that's less than 200 grams of materials, and the desktop computer still are several kilograms of materials. Or I can have a leaflet, either printed on paper, or I can download this leaflet on my tablet as a PDF and scroll through it on my tablet. And here you see the impacts from the paper version, which is set to 100% for each of these categories, and the PDF on the tablet, or the PDF read on a desktop computer. So in the end, the most sustainable way of advertising for a supermarket is if we read offline such a PDF on our tablet. A second example I've already shown at the very beginning, ICT could replace traveling. Now I have only shown the traveling impacts. I haven't shown yet the impacts from ICT. I come on this later. There are obviously also opportunities that are coming from new technologies. And we made recently a study where we were looking on the 5G network for mobile phone, only on the network. So we were not looking on the mobile phones. We were not looking on the data centers. We were only looking in this study on the mobile networks, 2 to 5G. The direct effect on one hand side, so establishing such an infrastructure, but also what are use cases that can benefit from a 5G mobile network? What is the potential reduction of greenhouse gas emissions that we can achieve in areas like agriculture, like transport, like the health sector, or flexible working? And we're going into the details, looking on if we can have more flexible work. This will cause a reduction of commuting. This will cause a reduction in office space. And we were trying to quantify these different use cases in order to see what is the potential of indirect effects that the establishment of 5G could bring in our country. Now, if we look on the direct effects, of course, if I'm establishing such a network, this will cause environmental impacts. You see here, 2020, 5G was at the very beginning. So the main impacts came from the infrastructure of the 2 to 4G networks because they were fully established. 2030, only 4G will remain, 2 and 3G will be disconnected, but 5G will be much larger. So the environmental impact of the 5G will be much higher. But in the same time, we will have the possibility to exchange much more data. And so if I break this down per let's say, on the data volume, then we see that the 5G network in 2030, according to our calculations, will cause 85% less environmental impact than today's network in order to transfer 1 gigabyte of data. That's the direct effects. Now, the indirect effects, of course, it's in a way, it's look into a crystal ball when you look on such indirect effects. But that's why we were trying to be creating 3 different scenarios, a pessimistic, an expected, and optimistic scenario. And you see here the ranges for these different scenarios. We were looking only up to 2030. Automotive driving is not something where you could expect that this technology will be fully developed until 2030. That's why the potential here is rather small, but for flexible working or for smart grid, the potentials could be rather high, going up to 0.8 megatons of CO2 equivalent saving per year in Switzerland. Of course, in order to do this, we need additional infrastructure. And so we don't only use the 5G network, but I need a second screen at home in order that I can do flexible work. We need some additional controlling elements in our electricity grid and so on. So here you see the impacts of these additional devices that are needed. However, if you look on the scale here, you see we are in a completely different order for this. So if I sum this up, on one hand side, the impacts that I'm causing, the yellow part that are the direct effects from the 5G network, the additional devices I need in order to make use of it, I have here, and here I have the reduction potential due to changes in my behavior. And we see that the blue bars, are each time much higher. So overall, 5G allows us to reduce significantly the greenhouse gas emissions if we make the right use of it. So overall, sustainability of ICT comprises a direct as well as an indirect element, and it results in changes in the behavior in our society. The direct effect clearly show that the smaller and the more mobile an ICT device, the more relevant gets its production. Hence, the longer in use means the more sustainable. And on the indirect side, changes, they can result in considerable reduction of impact, but we have to take care of eventual rebound effects. What are we doing with the time that we are liberating with the use of ICT? So overall, each of us is defining himself, herself, how sustainable his or her ICT use is. And this brings me back to my initial slides. So now I'm about 45 minutes with my laptop and with the internet on communicating with you, and this caused about 0.07 kilograms of CO2 equivalents. Thank you very much.